Hello and welcome back. In this lecture, I'll show you how to backup the configuration of all devices in our topology using Netmiko. I want to stress the importance of the backup process because in case of a failure, you can simply restore the backup in just a few seconds. This is one of the first things a network admin should do. This is our topology, the same we've used in the last lecture, and we'll start from the same baseline. The Netmiko script connects to the router, enters the enable mode, and then disconnects. We'll backup the configuration of one router, and then we'll add the part that does that for all the routers in the topology. The configuration of a Cisco device can be obtained by executing the showrun command. So I'm executing the command. I'm saving the output in a variable, and just to test it, I'm printing it out. So output equals connection dot send command showrun and print output. I'm running the script. I'll see the router's configuration. Perfect. This is the router's configuration. Instead of printing it out, I'll save it to a file, the backup file. The name of the file should be composed of the router's host name, the backup word, and .txt at the end. So let's get the host name. The idea is to get the prompt because the prompt consists of the host name and the hash sign. Okay, this is the prompt. So prompt equals connection.find prompt. And I'm printing it. It's okay, but I want to remove the hash sign at the end, and I'll do that using slicing. So host name equals prompt, a pair of square brackets, 0, colon, -1. This will return a new string starting from the first element, the element at index 0, up to the last one, which has index 1 excluded. The last element will be excluded. To make it clear, let's take a look in idle. For example, s equals and a string, Python. And now slicing. S, a pair of square brackets, 0, colon, -1. It will return a new string without n, which is the last element. Or -2, it will return a new string without the last two elements, the last two characters. And so on. This is how string slicing works, and if it's not clear, I'd recommend you to take another look at the string section where I've dived deeper into it. Let's print the host name. Perfect. This is the host name. Now I'm creating the file name using an f-string literal to concatenate more strings. File name equals f and a pair of single quotes. And between curly braces, the variable host name minus backup.txt. This will be the file name. The last step is to save the output of the command to this file. So with open the name of the file, file name, the mode, W, right? The file will be created as backup. This is a file object, colon, and backup.write of output. This is how you write to a file. And I'll also print out a message, something like this. Backup of hostname between curly braces completed successfully. And 30 hash signs to see it clearer. I'm running the script, and a new file called router1 backup.txt will be created in the current working directory. Here. Look, this is the file. This is the backup file. It contains the output of the showrun command, the router's backup. This is how we backup the configuration of a single router. Let's enhance the script to backup the configuration of all routers in our topology. For this example, to make it more general, I've created a file that contains the IP address of the routers to backup. This is the file. We've also used it in the last lecture. So I'm reading the file into a list. With open the name of the file, devices.txt, as f, and devices equals f.read.splitlines. This is how you read a file into a list. If you want to see the list content, you can print it out. The devices variable. It's a list and each element is an IP of the file. Having the list, I'll iterate over it and execute the code below for each element in the list, so for each IP address. Remember that you always use a for loop when you want to execute a repetitive task. So for IP in devices, colon, and I'm indenting the code below. This is the syntax of a for loop in Python. I'm selecting it and pressing on tab. And instead of this hard-coded value, the IP address, I'll use the temporary variable of the for loop, IP. At the first iteration, IP will be the first element, so the first IP in the list, in the file. At the second iteration, the second IP, and so on. Let's run the script. It's connecting to the first router, and the backup completed successfully. The second router, the backup is ready, and the last router. And it's done. And here, on the left side, we'll see the backup files of the routers. This is the backup file of the first router, the second router, and the third router. This is good, but not perfect. If tomorrow you return and run the script again, you will overwrite the file, and that's not good. Normally, you want to keep versions of your backups. For example, you backup the configuration once a day and keep 1 month of backups. This way, you can see the configuration changes that were made over time or can restore the configuration from a specific date in the past. So, we need the date and time in the file name. I've already explained in detail how to do that in the Paramiko section. Take a look there if you feel the need. Now, I'll just copy and paste that code. This code. I'm not using the hour or the minute, only the year, the month, and the day. And I'll add them in the file name. You can add them anywhere you like. For example, here I'm adding the year. I'll put an underscore here, minus the month, minus the day, and another underscore after the day. Or I can remove the backup word. It doesn't matter. And I'm running the script. Look here how will be named the backup files. Notice how the file names contain the host name and the current date. Now, we can keep versions. This script is very useful, but unfortunately slow. Just imagine how long would it take to backup the configuration of a large network with tens or hundreds of devices. Fortunately, there is a solution which is called concurrent execution, and it's implemented using multiprocessing or multithreading. Now we'll take a short break and I'll show you how to implement that in another lecture of this course.